Hello, Lakewood. We are going to get started on our unit on exponents and scientific notation. Let's go ahead and get familiar again with what exponents mean. I want you to look at this first number we have here, and how would you describe and say this expression to somebody else? So we would say it 4 to the second power. And this tiny number up here is called an exponent, which I believe most of you have heard of. Something that might be new is that when we have a number that's raised to a power and has an exponent, we're going to call that big number the base. How would you say this one? So this we would say 16 to the third power, because 3 is now our exponent and 16 is our base. And in this one, we would say 5 to the fifth power. So what exactly is a base? I'm going to give you the simplest term that I can think of. A base is the big number. It's the big number when using exponents. And the exponent, as you may recall, is going to tell us how many times the base will be multiplied by itself. So if we're going to expand this number out, 4 to the second power, well, that equals 4 times 4. Because we are going to take the base and multiply it by itself, where we end up seeing two numbers that are the base, 4 times 4. And that we would solve as 16. If we expand this expression out, we have 16 to the third power, which is going to be 16 times 16 times 16. And so what you would do to solve this expression is multiply these two numbers first, and then multiply this number third, and then we get our final answer. And what about this one? So now 5 to the fifth power is going to be, we want to see, this exponent tells us we want to see this base 5 times. So we would write it out as 5 times 5 times 5 times 5 times 5. And you can check yourself, especially when it's a big exponent. 1, 2, 3, 4, 5. Great. And we would multiply all of these together to find our final answer. One thing I want you to remember, if we were to look at 4 to the second power, this does not equal 2 times 4. 16 to the third power, it does not equal 16 times 3. And 5 to the fifth power, it does not equal 5 times 5. Let's just confirm this rule right here. And so let's solve this. 5 times 5 is 25. And I'm going to rewrite each of the 5s that I have left. 25 times 5 is 125. And now we have 2 5s left. 125 times 5 is 625. And 625 times 5 is 3,125. And if we are to come over here, 5 times 5 is 25. And those two things are not equal to each other. Let's take out our nifty table that is titled Properties of Exponents. So up here is a reminder of what an exponent is. And one important rule, we're going to go over some rules of exponents. One very important rule is that you always have to have the same base in order to apply that rule. And I'll show you what I mean. So let's start with the first one, the product rule. So remember that product means multiplication. So in general form, we're going to use variables first to express what we're talking about. So let's say we have the same base, and that's a, and it has different exponents, and those are going to be m and n. What do we do when we're multiplying two numbers, same base, different exponents? Well, we are going to add the exponents. That's how we're going to combine them together. Now we'll have one base, and we will just add the two numbers that were the exponents, and we will get our final answer. Here's an example with actual numbers. So we have x to the 5th power times x to the 3rd power. And that is the same thing and equals x to the, as an exponent, 5 plus 3. And we can simplify that to x to the 8th power. Remember that that's the product rule. So when we see multiplication, we add. Quotient rule. So quotient means division. And again, we have to have the same base in order for this to work. So what this rule is telling us is that, remember, division, when we see division and they have the same bases and different exponents, the way that we can solve this and simplify it is to just subtract the exponents. So an example is we have x to the 9th power divided by x to the 5th power. And we can combine and create one base and subtract the top exponent from the bottom exponent, and we simplify it to x to the 4th power. So when we see division, we are going to subtract the exponents. Power rule 1. A power is raised to a power. We multiply the exponents. So that one sounds a little bit confusing, but the examples are always helpful. So what we see here is we have a base with an exponent, and they want us to multiply this exponent with this expression. I'm sorry, I mean that we are raising this expression to the nth power. So a power raised to a power. Our application is that we are going to multiply the two exponents together. And our example is we have x to the 3rd power to the 4th power. So we have two powers. We can multiply 3 and 4, and that's going to become x to the 12th power. Power rule number 2. A product to power, distribute to each base. What does that mean? Okay, so we have two different bases, and they are both being raised to the same power of m. So remember our friendly word, distribute. We are going to So what you see here is actually incorrect, because what you want to do is distribute the m to both of the bases. And so our answer would be a to the mth times b to the nth power. And we can confirm that with our example. We have 4x to the 3rd power to the 2nd power. And what we're going to do is distribute that 2 to this term and distribute that 2 to this term, where we get 4 to the 2nd power times x to the 3rd power times the 2nd power, because we're using our first product rule. And we can simplify that. 4 to the 2nd power is 16, and we can multiply 3 times 2 to be 6. And this is in the simplest form we can get it. Negative exponent rule number 1. Flip and change the sign to positive. So, oh gosh, what if we have an exponent and it's negative? Well, we are going to turn it into its reciprocal. We're going to flip and change the sign to a positive. We do not want to have negative exponents. So the way that we rewrite this is the same expression in the denominator, and we have a numerator of 1. So an example here is x to the negative third power can be rewritten as 1 over x to the third power in positive form. Negative exponent rule number 2, flip and change the sign to positive. So what if, worst case scenario, we have 1 over a to the negative mth? What do? We change it back. So see how these two are opposite of each other, it's their reciprocal, and these two are opposite of each other, it's the reciprocal. If we had 1 over x to the negative fifth, we can change that and make it positive to x to the positive fifth power. Don't worry, we're on our last one. A 0 exponent. Anything to the 0 power except 0 is 1. A to the 0 equals the number 1. And that's true no matter what our base, what our A is, it's going to be 1. So we have something funky like negative 4x to the 0th power. It's going to be 1. The only time that does not work is if it's 0. In any other case, any other number or values here, it's going to be 1. All right, please watch the other video for some practice.